Welcome to our deep dive on the Tyrannosaurus rex. I'm so excited to uncover some amazing facts about this incredible dinosaur, especially its biology, behavior, and what paleontology has revealed about them. You ready to dig in?
Oh, absolutely. T-Rex is a classic for a good reason. There's so much to discover about these prehistoric giants.
Definitely. And I think a perfect place to start is with, Sue, of course.
Yes, Sue. More than just a fossil, she's a true icon. The most complete T-Rex fossil ever found. And her discovery was a story in itself.
Wasn't there some legal battle surrounding her I vaguely remember hearing about?
Oh, there definitely was. Quite a fascinating one, actually. A real fight over ownership. But ultimately, the original landowner won the rights. And then, get this, Sue was auctioned off.
Auctioned off. You're kidding, like a piece of art.
Exactly. And she went for a whopping 8.3 million US dollars. Can you believe that?
Wow, 8.3 million for a T-Rex fossil. That's wild. So where is Sue now?
She's got a prime spot at the Field Museum of Natural History in Chicago, a fitting home for the queen of the dinosaurs.
That's amazing.
Yeah.
You know, what I find truly captivating about Sue is what her bones have revealed about T-Rex in general.
Oh, absolutely. Sue's skeleton is like a time capsule, a wealth of information. For instance, she lived to be about 33 years old, making her the oldest known T-Rex.
33 years old. Wow, that's much older than I would have imagined. So these creatures could live for quite a while.
They could indeed. And Sue's bones tell us even more. She had her fair share of injuries, a torn tendon in her right arm, probably from a struggle with prey, and a deformed left fibula, likely from a nasty infection. Not to mention several broken ribs, probably from some pretty rough encounters.
Oh, wow. That's a rough life. I guess even at the top of the food chain, it wasn't easy being a T-Rex.
You got it. Even the king of the dinosaurs faced challenges and endured their fair share of pain.
I guess that's a reminder that even the most powerful creatures are still, creatures. They lived, they fought, they got hurt.
Exactly. It humanizes them in a way. It reminds us that they weren't just monsters in a movie. They were living, breathing animals with their own stories to tell.
Speaking of stories, I can't help but picture Sue in her prime. Just how big was she, exactly?
She was a behemoth. About 12.3 meters long, roughly the size of a school bus, and standing almost 4 meters tall at the hips.
Whoa, that's taller than a basketball hoop. I wouldn't want to run into her in dark alley. Or prehistoric forest, for that matter.
You and me both. And her weight. Estimated to be somewhere between 8.4 and 14 metric tons. That's heavier than 2 or even 3 African elephants combined.
Okay, now that's just mind-blowing. It's really starting to sink in why her discovery was such a momentous occasion. Sue is truly a one-of-a-kind find. So now, let's shift gears a bit. From Sue's individual story to T-Rex anatomy in general. What were some of their key physical characteristics?
Well, you can't talk about T-Rex without mentioning those famously tiny arms, those unusually short forelimbs with just 2 clawed fingers, so iconic. Although their purpose, well, that's still a bit of a mystery.
Yeah, those tiny arms have always puzzled me. It seems so strange that such a powerful predator would have such seemingly useless arms. Any theories about what they might have used them for?
Oh, there are plenty. Some suggest they used them for grasping prey, others for pushing themselves up if they fell. And some even think they were just remnants from their ancestors, no real use anymore. The debate rages on.
Fascinating. I guess some mysteries are just meant to stay mysteries, but hey, their hind limbs tell a different story, right? Those were incredibly powerful, I imagine.
You bet. Some of the strongest and longest legs, proportionally, of any theropod dinosaur.
So those powerful legs were what allowed them to chase down prey. Anything else particularly unique about their legs?
Oh, absolutely. They had this fascinating feature in their feet. It's called an arctometatarsalgian structure. Basically, the third metatarsal in their foot, it was pinched near the ankle.
Pinched near the ankle? I'm not sure I'm picturing that. How did that actually help them?
Imagine it as a kind of shock absorber. It allowed for more force to be transmitted through the foot with every step. So they were super efficient runners, despite their massive size.
Wow, that's incredible. So T-Rex was built for both power and speed, truly an apex predator. Now, I'm curious about their place in the bigger picture. They belong to a family called Tyrannosauridae, right? What can you tell us about their evolutionary journey?
Well, it's a tale that spans millions of years. Tyrannosaurids probably rose to dominance after larger theropods like the allosaurids and megalosaurids declined back in the early-late Cretaceous period.
So it was like they stepped into a power vacuum.
Precisely. And they evolved from smaller theropods, slowly growing in size over generations until, boom, you've got colossal predators like T-Rex dominating the landscape.
It's amazing how evolution works, from small beginnings to the king of the dinosaurs. Is it true that T-Rex might have actually originated in Asia?
It's a real possibility. They're incredibly similar to an Asian tyrannosaur called Tarbosaurus bataar. So similar, in fact, that some paleontologists believe T-Rex might have migrated from Asia to North America.
So the king of the dinosaurs, an immigrant. That's wild.
It just goes to show we're always learning and revising our understanding of the prehistoric world.
Absolutely. And speaking of revising our understanding, I have to ask about Nanotyrannus. I've read so many conflicting things about it. Some say it was a separate species, a pygmy tyrannosaur, while others say it was just a juvenile T-Rex. Where do we stand on that debate now?
Nanotyrannus. It's a real head-scratcher, even for experts. The discovery of Jane, a nearly complete juvenile tyrannosaur, really stirred things up.
So what's the main point of contention? What are the arguments for and against it being a separate species?
Well, some pointed to differences in skull features and hand proportions between Nanotyrannus and T-Rex, suggesting they were distinct. But others argued those were just changes that happen as T-Rex grows up, like dinosaur puberty, you could say.
Dinosaur puberty, that's an interesting way to put it. So is that settled, or is the jury still out?
The debate is still ongoing. A recent study in 2024 by researchers Nick Longrich and Evan Thomas Sayeda actually proposed that Nanotyrannus might be a distinct species after all, possibly even outside the Tyrannosauridae family.
Wow. So the mystery continues. It seems like with every new discovery, the story of T-Rex just gets more complex.
It certainly does. And that's what makes paleontology so exciting. It's an ever-evolving field with new evidence constantly challenging what we thought we knew.
Well, on that note, I think it's time to move on to one of the most hotly debated topics about T-Rex and their hunting strategies. Were they fearsome predators, or did they rely more on scavenging? I'm dying to know.
That's a question that has sparked endless debate among paleontologists. And believe me, it's more complicated than you might think. For a long time, people envisioned T-Rex as this, lumbering scavenger stealing kills from other dinosaurs. But, well, more recent evidence suggests they were active, dominant predators, although they probably wouldn't say no to a free meal if they stumbled across one.
So not just a scavenger, but a true hunter. That's fascinating. What kind of evidence points to them being predators?
Well, we have fossil evidence that suggests they hunted large herbivores, the duck-billed and Montosaurus, and even the heavily armored Triceratops.
Oh, wow. Taking on a Triceratops, that must have been quite a sight. Are there any specific fossil finds that really support that predator theory?
There's this really interesting Edmontosaurus fossil with healed bite marks on its tail. And guess what? Those marks are thought to be from a T-Rex attack.
So it survived a T-Rex attack. That's incredible. Talk about a lucky dinosaur. But if they were such skilled hunters, why did some scientists think they were mainly scavengers? What was that based on?
Some folks pointed to T-Rex's powerful sense of smell. Great at sniffing out carcasses. And their teeth, while formidable, were also somewhat blunt compared to some other predators. Some saw that as better suited for crushing bone than slicing flesh. But further research has shown that T-Rex teeth were actually incredibly strong and capable of both crushing bone and tearing flesh, making them pretty much ideal for a predator.
So a multi-purpose eating machine. They were clearly well equipped to handle just about any food source they came across. Now, think about their senses. We've talked about their size and power, but what about how they perceive the world? How do they see, hear, smell?
Well, let's start with vision. Studies of T-Rex skulls show that their eyes were positioned forward, so that gave them excellent binocular vision, just like us humans.
Really? So they could judge distances accurately?
Exactly. So they weren't just powerful and fast, they had depth perception too, and their sense of smell. Likely just as impressive.
I can imagine a keen sense of smell being crucial for hunting or even scavenging.
Absolutely. Research on their olfactory bulbs, the part of the brain that processes smell, suggests a highly developed sense of smell, maybe even comparable to modern-day vultures.
Fascinating. What about their hearing?
Well, it's likely they were well attuned to low-frequency sounds, detecting the footsteps of prey or even the rumbles of distant herds.
So T-Rex, a sensory powerhouse. Sharp vision, incredible sense of smell, and acute hearing. It's amazing to picture them using all those senses to navigate their world. Speaking of their world, what was life like for T-Rex back in the late Cretaceous period? I picture lush forests, but what else can you tell us about their environment?
Well, the continents were still shifting into their present-day positions, and sea levels much higher than today, creating vast inland seas that divided North America. The climate was warmer, more humid, And yeah, lush forests covered a lot of the land. It was a rich, diverse ecosystem.
It sounds like a vibrant world, almost tropical in a way. What other creatures shared this environment with T-Rex?
Oh, there was an amazing array of dinosaurs. In the northern parts of their range, T-Rex probably encountered, well, the iconic Triceratops with its three horns, the duck-billed Edmontosaurus, which we already talked about, the heavily armored Ankylosaurus, and even smaller, faster dinosaurs like Thescelosaurus and Ornithomimus.
Wow, that's quite a cast of characters. I can only imagine what it's like to see all these creatures interacting in their natural environment.
It must have been something else.
It's humbling to think about these creatures thriving in such a dynamic world millions of years ago. It really puts our own place in the grand scheme of things into perspective.
It really does. Makes you think, doesn't it? Speaking of diversity, let's talk about the different types of tyrannosaurs that existed. We've focused a lot on T-Rex, but they weren't the only members of their family, right?
That's right. What other notable tyrannosaurs were there? What made them unique?
There were a bunch of fascinating members in that family, each with their own special adaptations. For instance, Daspletosaurus. It lived slightly earlier than T-Rex, had a shorter, deeper skull, more robust build.
Kind of a stockier version of T-Rex. Were they as large?
Daspletosaurus was still a big predator, no doubt about it, reaching lengths of around 9 meters. But not quite T-Rex massive. Their stockier build might have given them an edge in different environments or for hunting different prey.
It makes sense that different tyrannosaurids would evolve different traits depending on their environment and what they were hunting. Were there any smaller tyrannosaurs, or were they all giants like T-Rex and Daspletosaurus?
Oh, there were definitely smaller ones too. One good example is Albertosaurus. It was slightly smaller than Daspletosaurus, reaching lengths of about 8 meters.
Okay, so there was a range of sizes within the family.
There was. And get this, Albertosaurus is known for having proportionally longer legs than T-Rex. Might have been a faster runner.
Wow, so even within the tyrannosaur family, lots of variation in size, build, maybe even hunting strategies. Did they all share any common features besides those powerful jaws and tiny arms?
Absolutely. Tyrannosaurids had some signature features. Their massive skulls with powerful jaw muscles, their sharp serrated teeth, perfect for tearing flesh and crushing bone, and their bipedal stance with those strong hind limbs and those, well, comparatively small forelimbs.
It's fascinating to think about how these features evolved over millions of years, ultimately leading to the iconic Tyrannosaurus rex, a testament to the power of evolution and adaptation.
It really is. When you look at the whole Tyrannosaur family tree, it's like watching evolution in action. You see these creatures gradually changing, adapting to their environments, becoming the top predators of their ecosystems.
Speaking of ecosystems, were tyrannosaurs found all over the world, or were they limited to specific areas?
Well, they were most abundant in North America and Asia, but there's some evidence suggesting they might have had a wider reach. We have some fossil fragments from Europe and South America that have tentatively been linked to tyrannosaurids, but we need more complete fossils to be sure.
So there's still so much we don't know about their global distribution. Makes you wonder what other discoveries are out there waiting to be made.
Exactly. There could be entire branches of the Tyrannosaur family tree that we haven't even uncovered yet. Paleontology is full of surprises. New fossils are constantly changing our understanding of these amazing creatures.
It seems like the more we learn about tyrannosaurs, the more questions we have. It's like we're peeling back layers of a mystery, and every discovery just deepens the intrigue.
That's the beauty of science. It's not about having all the answers. It's about exploring the unknown, always looking for new knowledge.
This deep dive has been truly eye-opening. We've covered so much. From their powerful bite, to their surprising senses, to the fascinating debates about their behavior. But there's still so much more to explore. I'm ready to hear more about these amazing creatures.
Well then, let's keep digging. How about we delve into the exciting field of T-Rex biomechanics? We can use computer modeling and engineering principles to understand how they moved and interacted with their environment.
Okay, I'm all ears. It sounds like we're about to blend paleontology with cutting-edge technology.
Exactly. Biomechanics helps us go beyond just looking at bones. We can start to understand how these animals actually functioned in their world.
I'm ready to dive into this T-Rex biomechanics. It sounds like such a cool mix of paleontology and technology.
It is, really. Biomechanics lets us go beyond just looking at the bones, We can actually start to get a sense of how these animals moved, how they function in their environment.
So how does that even work? Are we talking like building robot dinosaurs?
Well, not quite robot dinosaurs, but it's kind of close. Scientists create these really detailed 3D computer models of T-Rex skeletons using data from fossils like, Sue. And then they use this super sophisticated software to simulate things like muscle attachments, how their joints moved, even factors like gravity and the terrain they were moving on.
So basically, we're talking virtual T-Rexes. That's amazing.
Yeah.
What have they learned from these simulations? What kind of insights have they gotten?
They've been able to estimate things like how fast T-Rex could run, how strong their bite force was, even how they turned and, maneuvered themselves. For example, some simulations have shown that adult T-Rexes probably weren't as fast as we once thought. They likely topped out around 20 miles per hour.
20 miles per hour. Still pretty fast, if you ask me. Especially for something that huge. What about their bite force? How strong was a T-Rex bite?
Oh, phenomenal. Absolutely phenomenal. Simulations, along with studies of bite marks on fossils, suggest they could exert up to 12,800 pounds of force.
12,800 pounds. Whoa! That's like having 3 small cars crushing down on you.
That's one way to put it. No wonder they were such successful predators.
Yeah, with a bite like that. But even apex predators can't rule forever, right? What ultimately led to the extinction of these incredible dinosaurs?
It's a question that's puzzled scientists for, well, a long time. There were probably a bunch of factors at play. But the main theory is that a massive asteroid impact, the Chicxulub impact, set off a chain reaction of catastrophic events.
The giant space rock theory, right. I remember learning about that. Where did that asteroid hit and what happened afterwards?
It hit in the Yucatan Peninsula down in Mexico, and it's thought to have released this insane amount of energy, triggering huge earthquakes, tsunamis, volcanic eruptions, and all the dust and debris throw into the atmosphere. Well, that probably blocked out the sun, causing a rapid drop in global temperatures. Plant life would have been disrupted, food chains would have collapsed, basically a global apocalypse.
It sounds utterly devastating. It makes sense that so many species, even the mighty T-Rex, just couldn't survive such a dramatic and sudden change.
It really highlights how powerful nature is and how fragile life can be, even for creatures as strong and dominant as Tyrannosaurus rex.
It is pretty sobering when you think about it.
Right.
But their legacy lives on, right?
Yeah.
Not just through their fossils, but through the work of paleontologists who are constantly revealing new things about them.
Exactly. And that's the thing about paleontology, isn't it? It's a window into the past, a way to connect with these amazing creatures, to really appreciate the incredible diversity of life that's existed on this planet.
This deep dive into the world of Tyrannosaurus rex has been absolutely incredible. We've covered so much: their anatomy, their behavior, the world they lived in, even the technology that's helping us to understand them better than ever before.
I hope it's given you a new appreciation for the story of Tyrannosaurus rex. From their humble beginnings as small theropods to their reign as apex predators, and now their iconic status in our imagination.
It definitely has. It's mind-blowing to think that even after millions of years, we're still learning so much about these creatures. And who knows what other secrets are waiting to be discovered. There's always something new to uncover in the fossil record.
That's the beauty of science, right? And exploration. There's always more to discover, to learn, to appreciate about the natural world, both the past and the present.
Well said. To everyone listening, keep that curiosity alive. Never stop exploring, never stop questioning, and never lose that sense of wonder about the world around you. The world of paleontology is filled with amazing stories, and creatures like Tyrannosaurus rex, well, they'll continue to capture our imaginations for a long, long time. Thanks for joining us for this deep dive.